Hello everyone, I am Karthik Hiramat and let's meet our team Chandan SK, Chandan SG and Hemant D. So today we are here to present our project that is University Database Management System. So let's move to the contents part. Introduction, problem statement, objectives, methodologies, tools and technologies and expected outcomes. These are all will be there in our presentation. So let's begin with the introduction part of our project. A university database system is an organized collection of data designed to manage and store information related to students, faculty, department courses, and examinations in an efficient manner. In a modern educational institutes, what will happen? A large volume of data is generated and needs to be maintained accurately for academic and administrative purposes. Handling a such data manually is difficult, time consuming, and prone to errors, which makes the use of database system essential. The database system helps in storing data in a structured format using tables and relationships, making it easy to retrieve, update, and manage information. It ensures data consistency, reduces redundancy, and improves overall efficiency. By using a data management system, universities can support multiple users such as students, faculty members, and administrators simultaneously, allowing secure and controlled access to data. So this is how our introduction part looks like. Next will be the problem statement. A university database system is designed to efficiently manage and organize data related to students, faculty, departments, courses, and examinations. In a large educational institutes, handling a such data manual becomes difficult and very time consuming and lead to cause some errors like error prone. So therefore, a database system is required to store information in a structured manner and maintain relationships between different entities. The system helps in reducing data redundancy, improving data consistency, and providing quick access to information such as a student record, courses enrollments, examinations, results. It also supports multiple users like a students, faculty, and administrators to access and manage the data simultaneously. So these are all the problems which we found in the given problem statement. Next slide will continue by Hemant.
The entity relationship of this project is the entity relationship diagram is used to visually represent the structure of the database. It consists of entities, attributes, and relationships. In the entity relationship of this project is the entity relationship.
The entity relationship diagrams is used to visually represent the structures of the databases. It consists of entities, attributes, and relationships. In this system, the main entities includes student, faculty, department, course, examination, and enrollment. Each entity has specific attributes such as student having student ID, name, date of birth, and Department ID. The department entity acts as a central unit that is connected to students, faculty, and courses. The relationship between entities define how they are connected. For example, one department can have many students which represent one-to-many relationship. Similarly, one student can enroll in multiple courses and one course can have many students, which forms a many-to-many relationship. This many-to-many relationship is resolved using an associative entity called enrollment. The ER diagram also includes primary keys to uniquely identify each record and foreign keys to establish relationship between the tables. Cardinality specifies whether the relationship is one-to-one, one-to-many, or many-to-many. Next, going to the schema diagram explanation. The schema diagram represents logical structure of database in the form of tables. Each entity in the ER diagram is converted into a table with rows and columns. For example, the student table contains attributes such as student ID, name, date of birth, gender, and department ID. The department table consists of department ID, department name, while the course tables includes course ID, course name, credits, and department ID. And primary keys are also used to each table to uniquely identify the records, and primary keys are used to maintain relationship between the tables. For instance, department ID in the student table acts as a foreign key referencing the department table. The enrollment table uses a composite key consisting of student ID and course ID to represent the many-to-many relationship between students and courses. Data types such as int, worker, and date are assigned to each attribute based on the nature of the data. Constraints like not null, unique, and check are used to ensure the data integrity. And going to the output of our function, our project. The output of the database system includes successful creation of tables and insertion of data execution of queries. The tables display structured data with proper relationship maintained through foreign keys. Query outputs show meaningful information such as student details, course enrollments, and grades. The results confirm that the database is functioning correctly and efficiently. And then going to the normalization. Normalization is the process of organizing the data in the database to reduce redundancy and improve data integrity. In the first normal form, all attributes contain atomic values and there is no repeating groups. In second normal form, the database eliminates partial redundancy, ensuring that all non-key attributes depend on the entire primary key. In the third normal form, transmit transitive dependencies are removed, meaning that no key attributes depend only on the primary key and not on the non-key attributes. Normalization helps in avoiding anomalies and such as insertion anomaly, update anomaly, and deletion anomaly. By applying normalization, the database becomes more efficient, consistent, and easier to maintain. Next will be continued by Chandan. Chandan, next up.
Now, the SQL implementation. SQL stands for Standard Query Language, is used to create and manage the database. The create tables command is used to define the structure of tables, including primary keys and foreign keys. Constraints such as not null, unique, and check are applied to maintain data accuracy and integrity. The insert into command is used to add a records into the tables. At least 5 seconds, 5 records are inserted into each table to demonstrate the functionality of the database. Select query are used to retrieve data from the tables, while the where clause is used to filter records based on specific conditions. Joins are used to combine data from multiple tables, such as retrieving students' names along with the course they are enrolled in. Advanced SQL features like group by having and subqueries can also be used to perform complex data analysis. Next part will be continued by Hemant.
The conclusion of this project is, in conclusion, the university database system provides an effective solution for managing academic data in structured and organized manner by using ER modeling, relation schema design, techniques. The system manages data reduces redundancy and improves efficiency. SQL implementation allows easy manipulation and retrieval of data, making the system practical for real-world applications, the database can be further encased by adding features such as attendance tracking, online examination systems, and performance analysis tools, making it a scalable and reliable solution for modern universities.